So we're going to be multiplying these together. So the first thing I'm going to do is check to see if any numerator or denominator can be factored. I notice that this numerator can be factored by trinomials. This denominator can be factored by GCF. And this numerator can be factored by GCF. So let's go ahead and rewrite the product with each part factored. So for trinomials, you're saying what multiplies to 5 and adds to 6. So the factor pair that works here is 5 and 1. So my numerator would be x plus 5 times x plus 1. For my denominator, I notice that 7 divides both of these terms. So if I pull out a 7, I would have x squared minus 9 left over. And I also notice that this could be factored by difference of squares. So I open up double parentheses, alternate the signs, one's a plus, one's a minus, x squared splits as x, and 9 splits as 3 and 3, and the 7 would be in the very front. So my new denominator is 7 times x plus 3 times x minus 3. Lastly, for GCF here, I noticed that 7 divides both terms, so I would have a 7 on the outside and x minus 3 left inside. And then I have x plus 5 to the second power, which I'm just going to expand as x plus 5 times x plus 5. Once you have everything factored, you're going to look for pairs in the numerator and denominator. So for instance, I notice that there is an x plus 3 in the denominator and an x plus 3 in the numerator. That would simplify as 1. Next, I notice that there is an x plus 5 in the numerator and an x plus 5 in the denominator, and again, that would simplify as 1. Lastly, I notice that there is a 7 in the numerator and a 7 in the denominator, so again, that would simplify as 1. So let's take a look at what we have left over. So left over in the numerator, I have an x plus 1. In the denominator, I have an x plus 3 and an x plus 5. So now if I multiply straight across in my numerator, all I have left is an x plus 1. And in my denominator, I'm multiplying x plus 3 times x plus 5. So x plus 3 times x plus 5. This would be my simplified answer.